Assalamu alaikum, dear cadets. I am Sheikh Wajid Ali and I welcome you in today's class. As you could not come to your second home, Boishal Cadet College, that's why I am here to take your class through online because the world is seeing a very dangerous virus. Okay, so you should careful about class and your education because you did not come to college yet since 4 months or something like that. Okay, so boys, you should listen careful to this class. I hope you will understood the very important thing. Okay, let's start our class. Before going to take our class, we just say something about COVID-19. COVID-19 is the very dangerous virus because we don't know who is suffer from this virus because it will show his symptom before after 7, 10 days. So we don't know. So we should remain safe using the preventions of COVID-19. Like here, it is 7 steps for all of you. You should maintain these. Wash your hands frequently, avoid touching your eyes, nose, and mouth on unwashed hand, and cover your cuff using bend or elbow. And the main thing, you don't go outside, boys. If it's very necessary, then you will go and maintain this. Okay. Now our today's class, boys. Can you guess from this picture what we are going to learn today? Yes, it's Lami's theorem, and Lami's theorem belongs to statistics. Okay, so our today's topic is chapter 8 and section B, statistics, equilibrium, forces. After the lesson, you will be able to understand equilibrium of forces, apply Lami's theorem. Lami's theorem is very important. Okay, and last, solve problems of equilibrium forces. So our today's class is on statistics, equilibrium forces. So in previous 8A section, we discussed about resultant of forces. If the resultant of forces is 0, then the system is equilibrium. Okay, so this section we don't have any resultant. Okay, we have to find out the forces. These forces are in equilibrium. So what is equilibrium of a system of force? If a system of coplanar forces acting at a point be in equilibrium, their resultant will be 0. So if the resultant is 0, then the coplanar forces are equilibrium. If two forces acting at a point be in equilibrium, their magnitudes are equal and act on same straight line opposite direction. So if two forces acting at a point be in equilibrium, then their magnitude equal and the forces are opposite. Because you know that the parallelogram theory says R equal to P minus Q, the difference, if the forces are in opposite direction. Then if P and Q are equal, then R equal to 0. Then if the forces are same, equal, and same straight line opposite, that means 180 degree, then the resultant is 0. A resultant, that means resultant is 0, that the system is in equilibrium. If a body of mass m be placed on a horizontal plane, the weight mg of the body acts through downward direction, mg downward direction through the 90 degree with the horizontal plane, and the reaction R of the plane acts in the upward direction are equal to act on the same straight line along opposite direction. Then if the mass is lie on this, then the opposite reaction same force R. Okay, because this is one force and two force, and the two forces are in equilibrium. Okay, so R downward, mg downward and R upward, same. The magnitude they are same and the direction is opposite. Okay, this is the application of this. Okay, now if three coplanar forces acting at a point be in equilibrium, the resultant of any two of them is equal to the third, and they act along opposite direction. So if three coplanar forces acting at a point be in equilibrium, then the resultant of two force is equal to the third, opposite. Okay, opposite of third direction. Okay, now type 1. In this case, in this section, we just see some equilibrium state. Okay, so now one equilibrium state is that there is a sphere, and now let one end of a rope attached at a point A. Here A is a point on a vertical wall, that means AB is vertical, and here is a sphere. Okay, sphere, and then the weight of mg sphere is through the perpendicular downward with horizontal. This is horizontal, so it's perpendicular, and if there is a attached rope, that is AO, so there is a tension T. So here this is one force T, and this is one force weight, and the sphere is lie on the vertical wall. So there is a reaction force, that is R. So these three forces acting O point, and they are in equilibrium. Okay, so that is one state for our section. Okay, this is one type of problems. Now type 2. There is an inclined plane which is inclined through horizontal, inclined at an angle alpha. So AC be an inclined plane alpha to the horizon. If P forces, there is a particle, okay, if P forces acting parallel to AC, P forces, here is P forces, and the weight of the particle is through the downward. Always the particle through downward of horizontal, okay, horizontal through 90 degrees. Any particle, the weight of this particle makes a force, that is W, which is gone through the perpendicular of the horizon. Okay, not the place where it is. Okay, now here is, we just assume that there is a four forces, that is W here, and the W is not at any axis. Here if we choose this is an axis, it is, and it's, so there is an R, and if the bodies touch the line, the plane, then there is a reaction force, and their reaction force must be perpendicular to this plane. Okay, perpendicular to this plane, that is R is perpendicular to AC. And if air is a force W which is not goes any perpendicular axis, so its components, as you know, the resolution. Okay, so these W forces parts goes this side and this side. So there is four forces, P and R, normal reaction force, W sine alpha, and W cos alpha. These four forces is equal to the resultant of other three forces. Okay, now there is the most important point is if a system of coplanar forces acting at a point be in equilibrium, the resultant of any two of them equal to the resultant of other forces. Okay, so now type 3. The third is the law of triangle forces. Okay, in previous here there the 8a section, the resultant there, the triangle has three sides and its three sides has three forces acting, and their resultant you have to find out. And in this case, if three forces acting at a point can be represented in magnitude, direction, and sense by three sides of a triangle in order, then the forces are in equilibrium. Okay, so if the forces we have to define it in circular cyclic order, then it is in equilibrium. So now this is the three state type state of equilibrium I find out, and there are a lot of different. So if that three is basic. Okay, now there is two formula for solving this section problems. Also we use 8a section formula. There was parallelogram laws, sine rule of forces, and rectangular resolution. This three formula. Okay, now what is Lami's theorem? If three coplanar forces acting at a point along different lines be in equilibrium, then the magnitude of each is proportional to the sine angle between the other two forces. Let three coplanar forces P, Q, and R acting at a point O. It is point O, and OX, maybe there is OX line and its OY line and OZ be in equilibrium, then we can say that P forces divided by sine YOZ, that is YOZ, this, and equal to Q divided by sine ZOX, that is ZOX, others two forces, and R equal to XOY, that's forces. That is the sine angle between the other two. Okay. Now, formula 2. Condition of a system of coplanar forces are in equilibrium if the forces is more than 3. Then we use this formula. Okay. Now, let a system of coplanar forces P1, P2, P3 dot 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 Pn, here P1, P2, P3, Pn, and alpha 1, alpha 2, alpha 3, the forces makes angle with OX line or horizontal line with alpha 1, alpha 2, alpha 3, alpha n, and taking the resolved parts of the and there we can say that they are, if the resultant has these all forces acting, that's there must be a resultant. Okay, so their resultant is this angle makes angle theta, that is R, taking the result parts of the forces, we know that the resultant result part and the other forces resultant sum of the all forces result part is equal. So r cos theta, OX, along OX r cos theta, result part of resultant equal to P1 cos alpha 1 plus P2 cos alpha 2 plus P3 cos alpha 3 plus dot 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 plus Pn cos alpha n. But we know that the resultant is zero because all the forces are in equilibrium. If r is 0, then it's all equal to. That means this r1 equal to 0. That's p1 cos alpha 1, p2 cos alpha 2, p3 cos alpha 3 plus dot 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 pn cos alpha n equal to 0. Okay, but that's the on condition for along OX and perpendicular to OX, that is r sine theta equal to P1 sine alpha 1 plus P2 sine alpha 2 plus P3 sine alpha 3 plus dot 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 plus Pn sine alpha n equal to R2 also 0 because here R is 0. So that's all, sum of all these equal to 0. Okay, that's these two formula we use, and also the previous formula of 8a section we use for solving these problems. Okay, now I took 3 example of your textbook because your books, the example are identical. If you understood these examples, then you will understand the all problems of exercise. Today we will discuss some problems of example, and the next class I will take on this section 8b, and this class will be the discussion of exercise. Okay, so boys, let's start. So three forces P, Q, R acting at a point are in equilibrium, and the angle between P and Q is double the angle between P and R. Prove R squared equal to Q into Q minus P. So let the forces P, Q, R act at O along OA, OB, OC. Okay, OA, OB, OB, OC respectively, and angle between P and Q. P and Q is, let's say, P and Q alpha. So there is the angle between P and Q is double the angle between Q and R. P and Q alpha, the angle, and then the angle between, P and R is alpha. P and R is alpha, then P and Q is 2 alpha. And we know that the all sum of a circular angle is 2 pi. So this is the angle between R and Q is 2 pi minus 1 and 2, 3 alpha. So you know that the three forces and the angle between these forces. So you can use Lami's theorem. Now from Lami's theorem we get P by sine 2 pi minus 3 alpha, that is P divided by opposite two forces, angle between sine 2 pi minus 3 alpha, Q divided by sine alpha, okay, and R divided by sine 2 alpha. Okay, we know that sine 2 pi minus 3 alpha equal to minus sine alpha, and Q by sine alpha equal to Q by sine alpha, and these are same. So now for using simplifying, we know the sine 3 alpha formula. So that is P by minus 3 sine alpha minus 4 sine Q alpha equal to Q by sine alpha, and here R by sine 2 alpha, we use the formula of sine 2 alpha, that is 2 sine alpha cos alpha. And now simplifying that P by, we eliminate sine alpha because we know that sine alpha don't equal to 0. It shouldn't be, because if it is equal to 0, that's when alpha equal to 0, then the system will not develop. Okay, so p by minus 3, that is minus into minus plus 4 sin square alpha divided by q by 1 equal to r by 2 cos alpha. From 2 and third ratio, you can say r cos alpha equal to r by 2q. And first and second, we can say p equal to q minus 3 plus 4 minus 4 cos square alpha. We just use the formula of sin square alpha and cos square alpha. We know that sin square alpha equal to 1 minus cos square alpha, that is. And we use the value of cos alpha, that's q into 1 minus r by 2q, 1 minus 4 r by 2q whole square, that is q square by minus r square by q. So you finally find out the value of the ratio. So pq equal to p into q, pq equal to q square minus r square, that is r square equal to q into q minus p. So that's our desire. So we proved. Okay, next. Now problem 2, three forces P, Q are acting at the incenter O of the triangle ABC along OA, OB, OC respectively are in equilibrium. Prove that P is to Q is to R equal to cos A by 2, cos B by 2, cos C by 2. So here is ABC triangle and O is in center and OA, OB, OB and OC. Along these three sides, line, the forces P, Q and R acting. So, and you have to show that P is to Q is to R equal to cos A by 2 is to cos B by 2 is to cos C by 2. So we use just, since three forces P, Q are acting at point O are in equilibrium, then we use Lami's theorem. So using Lami's theorem, we can say P divided by sine BOC, Q divided by sine AOC, R divided by sine AOB. That is P divided by sine BOC equal to Q divided by sine AOC or COA or equal to R divided by sine AOB. Now, in class 10, we use or develop a formula, that is angle BOC equal to 90 degree minus B plus C. Okay, so use that 90 degree minus A. So now we use this. So here we don't use this directly. So now at firstly sine we can use, that is because we have to use, just understand what's in center. In center is the point, the straight line. Which straight line? The angle, the bisector of angles of triangle meets. So the line OA bisects the angle A, that is A by 2 and A by 2. And here also the line OB bisects angle B, B by 2, B by 2. And angle OC bisects the angle C by 2, C by 2. So angle BOC sine, we can now, it is B by 2 plus C by 2 plus angle BOC equal to 2 pi. So we can write, pi. So we can write angle BOC equal to pi minus B by 2 plus minus C by 2. So you can write sine into pi minus sine pi minus B plus C divided by 2. Similarly, you can say, we say sine pi minus C and A, C plus A divided by 2 equal to R divided by sine A plus pi minus A plus B by 2. So using quadrant rule, we write P by sine B plus C by 2 equal to Q by sine C plus A by 2 equal to R by sine A plus B by 2. So now is that formula what I previously say that we know the in class 10 we write down that the formula. So that is B plus, you know that A plus B plus C equal to 180 degree. That means A plus B plus C divided by 2 equal to 90 degree. So that's B plus C divided by 2 equal to pi by 2 minus A by 2. Okay. Similarly, C plus A by 2 equal to pi by 2 minus B by 2. And A plus B by 2 equal to pi by 2 minus C by 2. So here, using quadrant rule, P by cos A by 2 equal to Q by cos B by 2 equal to R by cos C by 2. So P is to Q is to R equal to cos A by 2 is to cos B by 2 is to cos C by 2. That's And now the third and the last problem we discuss today's class. Problem 3. A string of length L is attached to two fixed points at a distance d on the same horizontal line. A smooth weightless ring that means is free to slide along the ring and carries a weight W. So that ring will move smoothly. So no fixed. Okay, if L greater than D, then the length of the string is greater than the distance between the horizontal two fixed, and show that the tension of the string is W by WL equal to 2 L square minus D square root of L square minus D square. Now here is the fixed to point AB and distance between this and this D. And boys, listen carefully that if a smooth weightless ring, then that should make a tension T. That's same tension. Okay, tension T here and also T here, and its weight go through downward, makes 90 degree with horizontal. So let A and B be two fixed points and W act at the point C according to the problem. AB equal to D, S equal to BC equal to L by 2. So boys, here is the tricks. The tension is T, but if the weight is easily run through this string, then this will go under the half of the string. Okay, it will take middle position. So length of AC equal to length of BC equal to L by 2, and the tension T of the string will be same through the string. So boys, that's very important. You have to understand, if the weight ring is freely move, okay, then that goes the middle point of the string. So here is 3 force, and there is T1 force, and there are also T force, and there is W force, and these 3 force makes the equilibrium state, or we can use this as parallelogram law. Now W will be the result, and we previously say that if 3 forces acting, then 2 forces, and the third force is the resultant of the other 2 forces. So now 2 equal forces T and T acting at the point C. By parallelogram law of forces, we can write W square equal to t square plus t square 2t cos c. Here it is cos c, angle between these two forces, A angle, B angle, and here C angle. So now we can write 2t square and 1 plus cos c. And cos c is, you have to memorize the formula you see in trigonometry, that is cos c equal to a square plus b square minus c square by 2ab. And here we use, that's in figure, it is AC is L by 2 and it is L by 2 and it is D. So the C equal to cos C equal to L by 2 whole square plus L by 2 whole square minus D square divided by 2 into L by 2 into L by 2. Okay, so that is the formula. Okay, now simplifying this, 2t square 1 plus L square by 2, that is L square by 4, and plus L square by 4, that is L square by 2 minus D square, and here 2 into L square by 4, so it is L square by 2. So 2t square, and now L square by, take summation, then L square by 2 plus L square by 2 plus D square, and then 4t square L square minus D square, and this 2 minimize, that is L square minus D square, and here L square by 2, this 2 is gone through this, 2 into 2 4, so 4t square L square minus D square by L square, so t square equal to, then we know that's what is w equal to this, so here t square equal to 4 L square W square divided by 4 L square minus D square. So tension of the wing string is WL divided by 2 into L square. So it is the it should be, the tension of the string is, it is T square. Okay, so if we take square root, then it is WL divided by 4 means 2, and b square root of L square D square. So the tension of the string is WL divided by 2 L square minus D square. Okay, boys, that's all for our today's lesson. Now I give you some homework. Number 1, three forces PQ are acting a point are in equilibrium. The angle between them P and Q is 60 degree, and that P and R is 150 degree. Show that P equal to Q is equal to R by root 3. So just boys, that steps is, you just draw the figure and makes the angle between three forces, and then use Lami's theorem. And now problem 2. Three forces PQ are acting at the forces A, B, C respectively of a triangle ABC is perpendicular to the opposite sides in equilibrium. Prove that P is to Q is to R equal to A is to B is to C. So it is triangle related problem, and also use just the Lami's theorem. Okay. So now the third and last problem for all of you. A body of 20 pound weight is suspended by two strings, that the weight given and the string is two strings, 6 feet and 8 feet. Their other ends being tied to the extremist of the rod of length 10 feet. If the rod be held that the body hangs just below middle point. Okay, find the tension of the string. So the action is the middle point of the rod, and there is two strings, that means there should be two tension. Okay, just you have to just find out the tensions. So that's all for today. Now, before ending my class, I again remind you that the whole world is seeing a pandemic situation, and you must maintain the social decorum that the for preventing coronavirus. Okay, don't go outside, otherwise it's dire need. Okay, now stay cautious. Cautious is the most important, because our country is not in lockdown. Then every year the normal schedule is gone through, but the pandemic is not stopped. So you remain cautious, okay, just for saving yourself. And stay cautious, stay home, stay safe, stay fine. Thank you. Allah Hafiz.